In this video, we're going to continue our discussion of conic sections, this time focusing on the ellipse. So an ellipse looks a lot like an oval or a circle, and it behaves a lot like the other conic sections. So what this diagram shows you here is that I have an ellipse that could be horizontal, like this, or it could be vertical, like this. So it has 5 major parts. It has 2 vertices, right, here and here, 2 foci, it's got a center point, and it's got a major axis and a minor axis, depending on the horizontal or vertical alignment of it. So it also has a directrix, or actually it has 2 directrixes, and 2 latus rectums, which we can use, we can find them, but they're not as helpful here as these other 5 things. And the same with the other conic sections, like the parabola. You can have a center at the origin or not at the origin. So let's first talk about ellipses that have the center at 0, 0. So if I have one that has the major axis along the x-axis, this is the equation that I'm going to use, where I have x squared over a squared plus y squared over b squared equals 1. So with this one and the next one, x and y will always stay in this position on top, x first and then y second. It's going to be the a and the b that's going to change. The a value is always greater than the b value, and we're going to look for the value of c, which comes into play with the focus, and we can find that with b squared equals a squared minus c squared. So that all comes into play with the Pythagorean theorem, because I can actually draw a right triangle here. If I call this distance c and this b and this a, that's where all those numbers come from, hence why it's b squared equals a squared minus c squared. So I can find the foci at positive and negative c comma 0, and the vertices at positive negative a comma 0. So literally on the flip side of this, the center is still at 0, 0, but my major axis is now along the y-axis, so it's going to flip a little bit. I'm still working with the same elements a, b, and c, x squared, y squared, a is still greater than b, b squared equals a squared minus c squared, all that stuff is still the same, except I'm going to swap where the c and the 0 are in the foci, and where the positive and negative a is in the vertice. Now notice that if the major axis is along the y, this b squared comes first. So if you're ever looking at an equation and the second number here in the denominator is greater, you know that it's going to be centered at 0, 0, and it's going to be along the y-axis. And you would flip that for the last type of ellipse. So here I want to show you what I mean by that denominator. Now I have essentially the same equation, except the only thing that I've swapped is this 25 and this 9. Notice that the major axis is along the x-axis here, and the major axis is along the y-axis here. And I could find the foci and the vertices and the other points and measurements from the information from the previous slides. So as we know from parabolas, the center is not always at the origin. So we're still going to talk about center being h comma k, and we are going to use our a, b, and c values to manipulate and find the foci and the vertices and any major and minor axes depending on where that center is, h comma k. And that a squared and b squared, the rule from if it's centered at the origin, same thing applies, same thing applies. This one is going to have an a value that is greater, right? So a always comes first, no matter centered at hk or 0, 0. Same deal here. If it's parallel to the y-axis, that means that the larger value is underneath the y squared. Let's check out a quick example. So let's find the equation of an ellipse with the center at 2, negative 3. One focus is at 3, negative 3, and one vertex is at 5, negative 3. The first thing that I notice is that all of these y values are at negative 3. So that tells me that my major axis is at y equals negative 3. And therefore it's parallel to the x-axis. So I'm given the center at 2, negative 3, where h is going to be 2 and k is going to be negative 3. And I know that the foci is going to be h plus or minus c comma k. So I'm given this one, 3 comma negative 3, and I know that my k value is going to be negative 3. So I need to figure out the x value of the other focus. So what I've done is I've sketched out the 3 points that I've been given, and what I've found is that if my center is here at 2 comma negative 3, my focus is 1 to the right, and my vertex is 2 to the right from the focus, or 3 in total from the center. So if I look at the difference here between the center and the focus, it's 1, and if it's to the right, the other points, the other focus, and the other vertex are going to be to the left, so somewhere over here. And I know that they're going to be equidistant depending on the relationship that I already have here. So that means that my other foci, or focus, is going to be 1 comma negative 3. And I'm going to apply the same logic to find the other vertex that I'm missing. So if I went 1 here, I would just go 2 from that point. So I go from 1 to negative 1 comma negative 3, and I was already given that one. Another thing I could find is my b value. So remember that b squared is part of the equation that I have to write, and it also helps me find the points along the minor axis, which are going to be about here and here. I just add that value to the y, so that would be, if I'm looking at it, the point up here is going to be 2 comma negative 3 plus 2 rad 2, squeeze that in there, and the point down here will be 2 comma negative 3 minus 2 rad 2. So the next to last thing that I'm going to do here is write out the equation. So I was given this in the chart, and so I'm just going to plug in my h and k and a squared and b squared and set that all equal to 1. So instead of subjecting you to more of my terrible artwork, I used Desmos to graph this and some of the major points just to illustrate what we were talking about. So here's my center, my 2 foci, my 2 vertices. I have also sketched the 2, I labeled them M1 and M2, the 2 points that lie across our minor axis, and also the directrixes, just in case you wanted to see those. And that's going to do it for this video. Thanks for watching.